Hello, welcome. My name is Dalibor Topic, and I work for Oracle, right, as you can see here, as a principal product manager working on OpenJDK. I work from Germany, so I live in Hamburg, a beautiful port city. Our autumns right now are rainy, wet, and cold, so this is like a vacation. I've never seen San Francisco like this. This is awesome. Please keep it for next year's Open World. All right. And I'm here because I make the future Java. Actually, I help make the future Java updates. So before we get started, if you've seen any other presentation in Java 1, you've seen this slide before. If you haven't, take a moment to enjoy. I'm sure you expected this one, right? But you didn't expect this slide. Hands up. So hands up if you're using Java 7 already. Excellent. Very good. So in this presentation, I'll be talking about a bit about JDK 7 updates, how we make them, how they get produced in OpenJDK. So giving you a bit of a under-the-hood peek into the development of the whole thing. And I thought, what a better way to start this off than with a survey, of course, and then follow it by a demo. All right. And of course, the demo is in line with the theme of the conference, Make the Future Java. Let's do that. So since JDK 7 updates are being developed in OpenJDK, that means you can actually use Mercurial, HE, to clone the Mercurial repository. Screen sizes. All right. On java.net for the JDK 7 update project for the bleeding edge, the absolute bleeding edge of JDK 7 update development, JDK 7U-dev. That's where you go if you want to experience the pain, the latest fixes that have come in. So you do this, right? And then it goes off on our wireless network and requests all the changes, and it's 32 files and it's updated and it's done. Well, all right, that sounds like a very tiny JDK, 32 files. Let's look. What's in there? There is no code in here. All right, there's a file, get source. Let's do that. And then that file goes off and fetches all the other subrepositories that comprise the source code for the JDK. So Corba and JXP and JXWS and language tools and the JDK and hotspot and all of that stuff in parallel. And while it will be entertaining to watch for all this happen for a while, this is a Wi-Fi network, so let's not do that. Let's instead go to something I prepared somewhere else, where I have a complete clone already. So there we go. This is what it looks like once you download the source code. You have the Corba directory, you have the JDK directory, the hotspot, the JXP, and so on directories. So if you want to go and look in the source code, you can do it right there. But we're not here to look in the source code. We're here to build it, right? To make a future update. So I'm on a Mac, so I'm lucky. Building on a Mac is reasonably easy. If we were doing it on Windows, we would first spend the next half an hour setting the whole thing up. But on a Mac, all I have to do is a bit of voodoo, a bit of a magical incantation. So let's see. This. So I basically tell the shell that my locale is POSIX, and I tell the build system where to find Java 7 build to run the build itself from, because of course we're building the JDK here. JDK contains a lot of Java code which you need Java to build. So, all right, we've done this, voodoo, and then we make the future Java. This is a slow Mac, so this will go off and do all kinds of tests to see if I've set up all the paths correctly. It says sanity check passed, so that's good. It'll go off and start building stuff and compiling some more things. Compiling, in particular, Java C compile, the bootstrap itself. And this will now go on for a little while. Now I could end the talk here and just spend the next hour or so just telling you what is being compiled. Well, that's kind of boring, right? So this is just to show you how easy it is on a Mac to get started, to look at the source code and see what's happening in 7 updates in the OpenJDK. So all right, I'll quit that. That was the demo. And of course, if you're like me, in the middle of a talk in Java 1, and you just start off a JDK 7 build, you don't have time for that, well, you can do something else, right? So you can go here on jdk7.java.net, and you can download our developer preview builds that we publish regularly on a weekly or bi-weekly schedule for the next releases. So that means you don't have to do all this by hand. In particular, if you're running on Windows or on Linux or Solaris Spark or Linux ARM, you can just go and fetch these downloads under the Oracle pre-release software relation agreement license and run with these things. And of course, you can just go ahead and build this yourself from the OpenJDK source code and play with that. Or find somebody else who does this for you, like some people in the community do. So this is just to show you what's out there on 7 updates, to give you a feel for what you can get right now if you want to be on the bleeding edge. And with that being said and done, I'll just unplug myself again from network so that my wife doesn't call me in the middle of a talk. Since it's very late now in Germany, it's a great time to call, right before baby goes to bed. And I'll go back to the slides. Demo is done. It worked. I didn't use a Raspberry Pi. That's good. All right. So this is where you can find the early access developer preview builds. Right. So why are we doing this stuff? So why is all this stuff out there in OpenJDK so you can download it and build it yourself and play with it and all that? Well, if you looked on the OpenJDK 7 update project's website, and like any other OpenJDK project, it has a website. There is a single sentence description of what this project is about. The goal is to develop updates to JDK 7. Now you may be thinking, all right, so wait, didn't you guys have a JDK 7 project that went forever and then made a JDK 7? I mean, what happened here? I'll tell you. So back last year in June, Henrik Stoll, who's in the product management team responsible for Java SE, among other things, announced that we are moving to OpenJDK as the official Java SE 7 reference implementation. A reference implementation is the technical term in the JCP, and it basically means that we announced that we're going to provide a reference implementation for the new Java platform based entirely on the OpenJDK open source code and make that one available under the GPL open source license. And as you can see, the first line up there, that actually happened, right? So when Henrik says things are going to happen, they happen. So about a month later, we published the Java SE 7 reference implementation for download on java.net. And we published it on jdk7.java.net /Java SE7 RI reference implementation. And this one is based solely on all this open source code that the JDK 7 project accumulated over its couple of years' existence. And they're, of course, binaries for Windows and for Linux. But these binaries aren't for you unless you're actually trying to implement Java SE 7 platform spec yourself, right? They're there as a reference implementation. They're there like the golden meter or the golden kilogram in a museum in Paris. You don't go to Paris to weigh your fish you buy at the fish wharf, right? You go and use a local scale. But they're all checked against the reference thing. So it's a reference implementation. It's recommended for reference purposes only. It's been approved by the JCP. But being a reference implementation, it will receive no updates, in particular no security updates, right? We don't go to Paris and paint the whole thing new. It's a reference kilogram. It stays the way it is. All right. So with this JDK 7 project having completed its work and having delivered a reference implementation, the binaries, there was nothing left for it to do, so to say. So we delivered Java SE 7, big announcement, press release, last July. And then we had to do something about updates, because we could have, of course, said, all right, we deliver 7, let's go to 8 for the next 2 years. But it doesn't quite work that way, right? You want to have updates, you want to have bugs fixed, you want to have features, you want to have improvements. So for the first time, we had opportunity to actually go and look at how we deliver updates if we could deliver them in the open to begin with. if we could use OpenJDK as a vehicle to engage a community, to engage participants, not just from Oracle, but also from other organizations like IBM or Red Hat, to participate with us in development of update releases and the bug fixing efforts. So we proposed JDK 7 updates project in OpenJDK and decided to use that as the basis for our own Oracle JDK 7 update releases. So the Oracle JDK 7 updates aren't the same thing, but they're based off the code in OpenJDK. And of course, there's the website I mentioned before on openjdk.java.net, which has all the information on who the developers are, what roles there are in the project, and particularly how the development processes work. So what we do actually to make this stuff work and ship and make it high quality. And there is additional information on Q&A, so the typical questions and answers, and status updates on where we stand, what we're building towards, and what kind of fixes we're open for. You can get the source code, like I showed you, on ag.openjdk.java.net in the JDK7U forests. So we have a master forest, JDK7U-JDK7U. That's where we build releases from. That code has gone through integration testing. And we have a development forest. That's the bleeding edge. That's where developers get to push to. Right. And there's, of course, the mailing list. And on this mailing list, JDK7U-dev, that's actually where all the work happens on the updates. So that's where you go to when you have questions, when you have code you want to contribute back, when you have fixes and so on. All right, so this is the general structure about how all these things fit together, right? So in the next session of the talk, I'll go into a bit more detail into how actually all these things work in OpenJDK, so that when you get out of this, you'll have a good understanding of how to participate and how these things actually work. So first of all, updates don't make themselves. They're made by people, right? And the 7 Updates project, like all the other OpenJDK projects, has actually plenty of people involved in its creation and day-to-day work. There are reviewers. So in the 7 Updates project, we require code to be reviewed before it actually enters the source code base. There are committers, so people who have commit access, who can push source code changes into our repositories, the 2 I mentioned before. And then there are authors. Authors are a special role, so authors can create their own change sets under their own name, so they author changes, but they don't have the right yet to push these changes into the repositories. Because basically it takes a bit of time to get used to how the processes work and to understand all the things that need to be put in place to make this work. And you can see that there are a lot of individuals involved. I've played a bit around with fonts to show a few different roles. You can see that most of us are committers actually, but we've grown many authors over the last year. Many people coming in afresh and starting to work on updates. So in total, more than 200 individuals who are involved in some or the other way with the project. In part also who were involved with JDK 7 already and then remain in that role in 7 updates and just haven't done much, but that's okay too, right? You don't lose credit. And I currently serve as a project lead. That's, in my case, more of a ceremonial hat. The real work is done by my peers, by people like Edward Bendelin, by people like Sean Coffey, by people like Artem Daniev, who actually act as maintainers on the list and who do a lot of the work around approving changes, around reviewing changes, around making all of this stuff actually flow and happen. I get to be here and talk about all that. They do the work. All right, so if you want to see your name in lights here, you have to start backporting changes. And OpenJDK 7 updates, although we've done it JDK 7 and all that, is actually still a quite busy project. So there's quite a lot of work going on in updates on a day-to-day basis. There is a website called olo.net, which is, I think, these days run by Black Duck, if I'm not mistaken. So what they do is they will run an analysis with queued graphs over arbitrary code bases in Git or in Mercurial and so on. So if you go to the link below, you can find a summary for JDK 7 update project based on the JDK 7 U repository. And this is just a picture for the first 12 months. You can see that in the first year of the existence project, we had around 2,400 commits. So that pretty much breaks down to about 200 per month. Now, it doesn't mean that every month we check in 200 bug fixes, right? Some of these are things like somebody tagging the repository for a build. That still counts for all, but may not be a major change for you. Some of these are things that are automatically created by Mercurial as part of the integration process when we merge changes between repositories, right? But most of them represent real changes being made to either the JDK, to the language tools, to Hotspot, or to the XML libraries. And like I said, this amount of work takes quite a few people to be involved in, and actively out of these 200 people with roles in OpenJDK, in the first year, more than 100 have participated and contributed a change in one way or another. So there you can also see that there is typically more than 20 people involved every month in the project itself. And this brings me to the real inner mechanics of how these things fit together. So in OpenJDK, we have bylaws which have certain rights and duties for participants, and which also set expectations on how projects like the OpenJDK 7 update project are supposed to operate. Right? So if you read our bylaws on openjdk.java.net/bylaws, there's a sentence in there, or a couple of them, that says projects are expected to operate in an open, transparent, and meritocratic manner. So open, transparent, meritocratic. That's good. And if they don't, their alignment with these principles will be monitored by the governing board. So to keep us honest. So when we started to think about doing JDK 7 updates in the open, we had to think quite hard about how to do this in an open and transparent and meritocratic manner, because it hadn't been done before. This is the first time that actually updates to a JDK are being done in the open. That means when Edward and I started thinking about processes, we had to first come to understanding how the processes for Oracle's JDK so far had worked, so that we understand what happens on the close side, what to plug into, so to say. But we had also to understand what our downstream users, like IST and others, had, what kind of needs they had, so that we could come up with processes with the community as part of the discussion on mailing list that worked well for everybody and were in alignment with these principles. So we spent quite some time on that in the beginning, in setting up our various rules and setting up various ways to make code flow between the repositories to ensure that what we end up with actually works well. And I'll go into a few of these processes we have in the presentations just to give you a feeling for the challenges we had and how we tried to solve them. So the first thing we wanted to do was to set up some ground rules. We had a very good example in the form of the OpenJDK 6 project led by Joe Darcy. Joe had created OpenJDK 6 back in 2008 by taking the JDK 7 code base and effectively cutting it down to the appropriate pieces, appropriate APIs to be able to deliver a fully open source Java x6 implementation as part of OpenJDK. But at that time, of course, Sun JDK 6 at the time had been in full flight, right? So there was no real crosstalk between the two possible. So in some ways, Joe had the liberty and the joy to be able to set his own rules in relative splendid isolation, which was great because he could actually experiment with some new ways of doing this kind of work with the community in the open. And that was for us, for Edward and me, good inspiration. But it wasn't something we could take as is and implement in 7 updates, right? So the way OpenJDK 6 worked was a good way for us to learn from, but not something to copy one-to-one. Similarly, since these are updates to JDK 7, you would think, okay, we can just take the process for JDK 7 and run with those. But it doesn't really fit, right? So a project like JDK 7, a JDK release project, typically stretches over multiple years, say 2 years. So it has a very different kind of process in place with milestones and everything. It's a lot of time, so to say, to correct errors. Updates, on the other hand, we deliver update releases very frequently, effectively every couple of months. And that means the development cycle is much more shorter. And that means that we have to put some thought into how we can work together in a quick way, how we can avoid having mistakes to begin. So when we started, it was clear that we needed some ground rules to set expectations about how we wanted to operate the project. And the first rule we ever created was to say, we have processes, we'll develop these in the open, and they will change in the open. And since we created put the process in place last year, we had a couple of changes, a couple of small tweaks to make some things better. But in general, this is set up really well. So it's also a bit of a, how to put this, it's also quite useful as a barrier to entry to bad ideas, because you know any idea you have, a proposal to change, will have to be discussed publicly, right? So it's a good rule to have. The second ground rule was about development. So how do we avoid a situation where we end up having a lot of fixes contributed to 7 updates and nothing to 8, and then being in a situation where we are almost ready to release 8, where there are hundreds of things left over to forward port and test, right? Nobody wants that. So what we did was to have another ground rule to tell developers to get the changes into 8 first. Right? 8 first, and then please backport them. And that ensures that whenever there is a bug fix, it goes into 8, it gets tested in 8. It goes into 8 early access builds that George Saab mentioned in the keynote, so that you can try them out as well. And then after a while, developers can bring it back into 7 updates and ask for approval to backport a change and push it in.
Just a quick question. If you are kind of working on a critical security fix that has, is time, critical, do you follow that procedure as well, or?
So security fixes don't happen in OpenJDK. That would work, right?
It would work, but it just takes some extra time.
So we don't do this in OpenJDK. It just couldn't happen for us. What we have, though, are forests, right? So we have these master forests with integrated code. We have developer forest, and they all have maintainers. So they have somebody in place who can approve changes, who acts as a gatekeeper, who ensures that changes coming in meet their expectations, who ensures that the changes coming in, for example, are free of things that shouldn't be there, right? But also include things that should be there, for example, test code. So the maintainer role is a role we kind of invented for this project as a sort of a gatekeeper between developers wanting to backport changes and get fixes in there, and actually ensuring that what comes in here meets all of what we need to be able to deliver a good release in open source. And changes in Rule 3 coming into 7 updates, we want these changes to be publicly reviewed. We want to profit from having many eyes looking at code being backported. And the approvals for these changes also have to happen in the open. And that ensures that everybody knows when somebody's proposing a fix, that that fix actually is approved for 7 updates or not. Right? So that doesn't happen behind closed doors. The approval for a fix happens in the open. These approvals by maintainers are done centrally on the JDK 7 U-dev mailing list. That's the mailing list we use to work on 7 updates, but it's not the only mailing list we use to work on 7 updates. So for example, for a project like the macOS 10 port, a lot of the work on actually implementing fixes and actually doing the necessary reviews and all these things happens on the macOS 10 -dev mailing list, where the experts for macOS 10 ports are. And then once the fix is approved, once it's in 8, after a while, once it's basically shown its worth in 8, it gets backported to 7 updates. And then the approval request comes to the maintainers on the JDK 7 U-dev mailing list. And that ensures that if you're following just the JDK 7 U-dev mailing list, you see everything happening patch by patch. So you see all that play. You don't have to watch necessarily all the reviews, but you see what's happening for the updates. Maintainers, since we don't all live in the same time zones, for good or bad reasons, are pretty much like Germany. Maintainers also can pre-approve changes, right? So when you know that a bulk update for Hotspot is coming, you can say, all right, I approve this one ahead of time. And you can also, on the other hand, ask for additional reviews as a maintainer. So if you're unsure about a change, about its effect, you can ask somebody to have another look at it, to make sure that it all matches our expectations. So in that sense, maintainers act as a glue between all the different stakeholders, as a connection between developers and users and everybody else. And one last rule we have here, or two actually, is that changes coming to 7 updates should be plausible. They shouldn't just appear out of nowhere. So they should have some kind of review trail, they should have an approval request. They shouldn't just appear out of thin air in the repository, because it makes everybody nervous, right? And being nervous is bad. So we don't want that. So these are the ground rules. And after a year or so of living with them and slightly tweaking them, I think we're actually doing a pretty good job of following along with them. So of getting development happening in a transparent and open way, and using the JDK 7 new-dev mailing list as a central resource for everybody interested in following the project to inform them of everything that's happening. We've had to do quite a bit of work over time. We learned quite a bit. As we started, we didn't publish information on, say, schedules and these things. Over time, as we spoke with the community using JDK 7 updates downstream at conferences like Foston, we learned a bit more about their needs and started to communicate more about, say, our release schedules. All right, so that's the ground rules. Now, of course, ground rules means you have rules, but where's the code? Right? So I said we want to have code that's reviewed. And for code reviews, we have a bunch of rules as well. So code reviews have to happen in public for 7 updates. We do get some code from other projects, like, say, Hotspot or JDK 8 or Corba and whatever. In these cases, we don't go and police them. But if there is code that's specific for 7 updates, that has to be reviewed in 7 updates, it gets reviewed there. There is, to ensure that developers have a reason to actually go towards 8 first, there is a fast path for approvals from 8 in the case of unmodified backports. So if the code doesn't actually have any modifications, if it's a one-to-one comment patch, you're applying again, that's okay, right? There's also a slow path for backports with modifications, when you have to go in and change a line or two to make the backport work. Then we know we need to have somebody else look at this code again, just to ensure that what comes in here actually works, and actually works everywhere, and works as well as we expect it to work. And in line with that, we require at least one reviewer to look at any change coming into the mainline forest. And once we come towards a release, once we start ramping down to a release in our process, so we keep our mainline forests open all the time, but at given points in time, we will ramp down and start to raise the bar for what kind of fixes come into release. And once we start doing that, we create a new forest for release. So for example, if you go to our Mercurial repositories, you will find 7U6 forest for the last release. Then we also raise the bar for number of reviewers, so it's at least 2 that have to look at the changes coming in. And it also means, as a recent addition, that when you're backporting changes from 8 into 7 updates, we also want you to make sure that you have spoken with your reviewers in 8. In particular, if you're backporting somebody else's code, right? We want to make sure that everybody who may know something about the change is involved in this process and can voice their opinion whether that's a good backport or not. Because of course we can't just take anything from 8 and put it to 7 updates. If somebody adds a new method to string in 8, we can't put that in 7 updates. That doesn't work, right? And of course, this is also all part of how we develop 7 updates in the open. When there are questions about the backporting process, we discuss them on the mailing list. So a week or so ago, we had a backport request coming in for some documentation change, which was touching upon Javadoc. And we had to discuss first whether we actually want to have Javadoc changes coming to 7 updates in something that's either spec relevant or implementation detailed. Involve people like Joe Darcy, who do the CCC work at Oracle, to make sure we get a good reply, to make sure we get a good solution. And now we are able to include, say, implementation note, documentation fixes in 7 updates. Well, that's the job of the maintainer. The job of the maintainer in a project like this is to bring the various parties together, to bring the various areas of expertise together on compatibility, on backporting, on development, and on the subject matters. And after a year of doing this, pretty much all of the stuff that's happening in 7 updates itself is actually done according to these rules, with public reviews and following the fast path usually. There are some cases when we have new people coming in who then unwillingly break a rule or two. Typically, they mean no harm, right? It's just somebody who's new at Oracle and is doing something new and is trying to push the changes in before the 5 p.m. deadline strikes for the next build, which is 2 a.m. for me in the morning, so they can't reach me. All right. And then it typically is a sane change, so we can retroactively approve them as maintainers, and we have a small chat with them. So standard rules, and love them as much as we do. So this is an example request, right? So this is a request that actually happened on our JDK 7 update mailing list from somebody at Oracle backporting a fix for a particular bug into our development forest. And as the mail says, this fix had been pushed in exactly the same form into 8. The change is exactly the same for 7 update 10. There's a link to the corresponding bug report in our bug database so that you can actually get more information about the bug itself, if there are any related issues that should be considered for the backport, for example. That's something that I like to do as a maintainer, to make sure that the backport has considered all the related things that may need to be backported as well. In case that the bug is closed, we typically ask the submitter to also, to instead of submitting a link, give us a description of the change so we can review it if necessary. There's a point that the JDK changed that. In this case, it's in the 2D forest. So this is a AWT change. There is a WebRef. WebRefs are our own format or tool we use to be able to review code on our code review server, CR OpenJDK. And then in this case, there's also a review thread that you can also, which is also public, of course, that you can go and look at in our mail archive and see what happened when this was proposed. So did this patch have to go through a couple of iterations? Was this a controversial change? Was this something that was actually quickly approved? Are there things that have been pointed out during the review that I need to consider when we backport this into 7 updates? Are there things that we need to ask additionally of the reviewer? Did it turn out that this patch was only tested on, say, one platform? Do we need more tests here? Right. And you also get to know who reviewed the change. So in these cases, the reviewers in 7 updates project. And we get a lot of these, right? So, like I said, there are hundreds of changes coming into change sets coming into a forest. So we get quite a lot of this kind of email. And as a maintainer, you get to look over it and make a decision whether to approve it or whether to ask for more information, ask for reviews, and so on and so on. This used to be slower, but these days, thanks to the great work done by Edward and Sean, we're able to usually process these things, say, within a day or so. Except when it's a weekend, of course, or holidays, or it's Java 1. All right. But usually, it's about a day or so. Because, of course, you also don't want to just slap these away. You want to give people opportunity to chime in if there's something that they want to bring to discussion. All right. So that's regular code changes. But, of course, there are also bits and pieces in the 7-update code base that we get from other projects, like I mentioned. So in the 7-update case, that's a hotspot, that's Corba, that's JXP, and JXWS. Since they typically are developed in a different OpenJDK or Glassfish project, they typically accumulate more than one change. So for them, we have a bulk update process, bulk change process. And that means maintainers get to be the traffic cops regulating this bulk change traffic. They can also ask for additional reviews in case it's necessary. And of course, since these changes can be quite significant, they require approval, like any other change, but they also have to build everywhere and pass all the tests. So we explicitly ask a contributor requesting a bulk change approval to ensure that all the tests have been run and all tests have passed, right? Because bulk changes, like hotspot, they concern everybody. So if you've broken hotspot in your bulk change, you've broken everybody. That's bad. So that's why we, for bug changes, have higher rules on what we accept and what we don't accept. To give an example here, this is what a bulk approval request looks on our mailing list for a hotspot integration. So our integrator is requesting to integrate a specific hotspot build into a specific JDK 7 update build. There is a pointer again here to the web rev, so you can look and see, as anybody on the list, of course, as a maintainer, what exactly is contained in this web rev. There is, in this case, the statement that testing is in progress. The integrator will hold off until our quality engineering team has basically approved this integration. And it also contains a list of all the fixes contained in this bot integration, so that as a maintainer you can look and see, is this what I expect to see? Or is this something entirely different? Right? And that means you can follow along even as hotspot is integrated, at what level we are and how far along we are. All right. So in the unlikely case that you have a fix, right? And you're wondering, all right, so I used 7 updates and it broke my ant or something, and I don't know, I fixed it, so where should I go? Well, if you don't know, please ask on the mailing list, right? And I'll be glad to help you. And the thing is, we'll likely tell you to go somewhere else. Right? As I said before, we won't fix this to go into 8 first. So we would like to tell you, please go to 8, or please go to Hotspot if it's a change for Hotspot, or please go to the Glassfish project for JXP for change in this area, and contribute your fix over there, right? And get it through their testing first. Get your fix accepted and integrated into a JDK 8 build. And once that's done, once a certain time has passed, once your fix has acquired a nice patina of goodness, right? Then come back to us later with a backport. And make sure your reviewer is also aware of your intention to backport a change. And that's basically it if you have a fix, right? It's not as hard as it looks. It's a bit unconventional because you will get told to go somewhere else, but it actually works. So we do get a steady stream of contributions from people like Andrew Hughes here, or from developers from IBM, who are pushing that change into JDK 8 first and then bring it back into 7 updates. But of course, not everything is that easy. There are some cases that are special. One of these special things is integrating a new operating system port into the JDK. That happens very rarely. And it just happened in 7 updates that we got a new port for OS 10. So back in the beginning, in the early days of OpenJDK, there was a porting project for BSD platforms, for NetBSD and FreeBSD and OpenBSD. And all was good. And then along came Landon Fuller and contributed a port to the BSD porting project for Darwin, or in other words, for the Mac. And all was even better, right? But it was basically it was X11 based, so it wasn't quite up to the standard of, say, somebody using NetBeans, right? So in 2010, Apple and Oracle announced a new porting project for macOS 10, based actually on the Darwin on the BSD port on this Darwin code base, and we started a new project in OpenJDK for this, with contributions from Apple, contributions from Oracle, to bring this code up to speed, to bring it to a level of where it can be integrated into JDK 7. Now, we didn't integrate this into 7 proper because it was too late, so to say, at that point. But of course, that meant we could look into updates. So in 2011, we created an interim forest, JDK 7 U-OSX, where the code from macOS 10 port migrated into. That's the forest we use to bring the code in macOS 10 port in alignment with the code in 7 updates, right? Piece by piece. And then a couple of months later, in early 2012, it was integrated into JDK 7 U-Dev forest. And it was then forward ported to 8. And you'll say, wait, you said go to 8 first, right? What happened here? Well, an operating system port is, for an operating system we didn't support before, like OS X, is actually quite a bit of work. It touches a lot of code. It touches hotspot, it touches class libraries. And at that point in time, we'd already undergone a couple of months, or actually more than half a year, of development on 8. So 8 had stampeded on steadily in that sense. And it made little sense for us to make the macOS X porting team first go to 8, implement all the new stuff in 8, do the Lambdas first, guys, right? And then come back to 7 updates years later. We didn't want that. We figured you would like very much to get your JDK 7 updates at the same time everybody else gets them, if you're on a Mac. So for the OS X port, we went to 7 updates first, and then brought the code forward into 8, where it is being maintained now. So if you have a change, a bug fix for Mac right now, same answer as applied as before. Go to 8 first, please, and come back later when the code is ready. And this is also a good example of how our development works for 7 updates. While the approvals for this code base are discussed on JDK 7-U-dev mailing list, most of the development work actually is discussed on the corresponding macOS X port mailing list, right? So that's where people will come in with macOS X questions and get macOS X answers. And that sort of helps keep conversations contained to different communities. So that's a lot of effort. So what do you get for this? Well, we got a couple of releases so far that have been developed from the beginning till the end in OpenJDK. The first one was the OpenJDK 7 Update 2 release. And like I said, the first ever update release that was done in the open. It was released in December last year and contained, among other goodies, a new hotspot version. So where JDK 6 stayed on the hotspot version 20, I think, 7 updates have since moved along to newer and newer versions, bringing performance and reliability improvements. Then, of course, we did bring in support for a new operating system for Oracle Solaris 11, but it was just a new revision of Solaris, right? It wasn't a wholly new thing like OS X was. We had, since this was the first normal release after 7, we had some bug fixes for interesting 7 features. So Project Coin, for those of you who know it, in 7, had some really nice language changes that are simple and small, but even if it's simple and small, you can still have bugs. So there were 2 bugs that we actually fixed in the first OpenJDK 7 update release. And then, of course, all kinds of other bug fixes and updates to information we carry as part of the JDK, for example, the also on time zone database. The development period for this took from approximately 6 months, from about July until December, right? To give you an idea of what I mean when I say that the processes have to be different from a JDK release. The JDK 7 release took about 4.5 years. It has to be much faster. It's a meat grinder for patches. So okay, this worked well. We did the first update in the open. Hey, let's challenge ourselves. Let's integrate a new operating system. So we did that, right? So we did the integration of a new port, the new operating system, in the open. So the macOS X port, all of this stuff with bringing up a new forest, dragging the code from one forest to the other, was discussed on our mailing lists. Was discussed, and the forests were created, was approved. All of that process ran through to bring the port over from macOS X porting projects into 7 updates and into 7 updates proper. And we released in April this year. We also started to publish the source code for update releases, 7 update 4 and later 7 update 6, as source code bundles on Java, jdk7.java.net. So that if you're, for example, packaging OpenJDK 7 updates, you don't have to go and pry this out of Mercurial yourself, like I showed you before. You can just go and take the zip file and use that instead. We've integrated the macOS X port at that time as a developer preview of the JDK. We integrated the new hotspot version, 23, and did the usual set of updates like the also on time zone database, upgraded JXP, and have introduced a new supported garbage collector. So with 7 update 4, garbage first became a supported garbage collection option. And that too is something that requires a lot of testing and a lot of care to make happen. And to conclude the first year, we had a third release done in OpenJDK, 7 Update 6. And that one was released in August of this year. And since we had, done the first release in the open, into the new port, in August we basically had nothing left to challenge us with. So we had a normal release, just regular stream of bug fixes. We completed the work on the JDK and JRE support for OS X. So rounded off the corners, made it magical and revolutionary as it should be. We introduced an alternative hashing function into 7 update code, which is in 7U actually disabled by default, but there is a system property you can use to enable it. And in 8, we enable it by default. And that shows a bit how we, in 7 update, proceed to ensure that there is very little disruption for users updating. Right? If a new functionality can cause disturbance, we prefer to be conservative in update release and then do the revolutionary thing in a regular release. And then, of course, time never stops running. In particular, time zone changes never stop running. With more than, I think, 200 countries in the world, somebody always has a good reason to change daylight saving time. So, of course, as every other release, this one also had an awesome time zone database update and various other bug fixes. And I hope this has given you a bit of an insight into the mechanics behind the sausage making that goes into a good, tasty 7 update release in OpenJDK. So if you want to help us make the future Java 7 updates better, please get involved. Please download our developer preview builds on jdk7.java.net and use them to test your code. Use them to use the early access versions and run them against your own, whatever you're working on. Because the thing is, what we can test with is just a tiny part of the iceberg of all the code out there that's above the water. All of the other dark matter of code, we don't have access to it. You do. So you have to let us know when something is going to 7 updates, has issues, and causes regression, for example, for you in your testing. And by doing this in the open, by allowing you to see the work on 7 updates as it's happening, patch by patch, change it by change it, you have the opportunity to participate in a way that lets us find out such issues as soon as possible, so we can go and fix them as early as possible. And we can deliver high-quality updates to you. And of course, if you want to go beyond just getting a binary, trying it out, and submitting nice issues of bug tracker, which is always appreciated, the first step is to become a participant in the JDK 7 update project. And that's actually as easy as subscribing to the JDK 7U-dev mailing list and starting to listen to the conversation and starting to participate in discussions of the changes being backported. And with that, I'd like to thank you. Yes, please.
How do you prioritize the modification? I mean, there are many bug reports and it has many different things for a feedback to be. How do you choose which should be fixed?
All right, how do we choose which should be fixed? So, since we have the pleasant, setup where we ask people to go into 8 first, right? We actually are able to avoid having most of that choosing and picking responsibility by having the 8 project serve as our petri dish, right? So if a fix is controversial, it gets discussed in 8 first. It gets flamed around in 8 first. And then hopefully it gets, to be a good piece of code integrated into 8 well hung out there. And by the time it's proposed for 7 updates, it's no longer controversial. It's been out there for weeks or for months. Everybody's okay with it. It becomes a much simpler process, right? So we don't have to do so much picking ourselves to 7 updates. We do that work for 8, of course. And that really depends on what one is doing. So I'm not sure how you, for example, choose your issues you want to fix at Red Hat.
We choose them based on the seriousness of the issue. If it's JDK crashed, if we talk about it, it's a minor annoyance.
And we typically have the similar things for us as well. And the thing is, due to the various different parties coming together in an open source project like this, they may have different areas they care more about than others. Meaning that, if you say, find an issue with ICE-T, which is based on OpenJDK 7 updates, or running on Fedora, or Rails 6, I think, and file a backtracker there, it'll eventually, hopefully, lead to a fix that shows up in 8 and 7 updates to the Red Hat team. If you file a backtracker with our backtracker, somebody in our team is going to look at it and decide if it's something that we need to be fixing right away or something else. So in that sense, in a project like this, there is no central authority to make the sort of priority decisions. Because nobody signs up for that. Everybody signs up for fixing the code they care about. But in a project like that, you're going to have many people who care about many areas of code. And that's what we are starting to see. Well, I'm glad I've left you all speechless. So this was a magical, revolutionary presentation. Thank you all so much for coming. Enjoy your lunch.